Hello everyone, we are here with our guest for the first part of this open space. Is Dmitry Jemerov. Ben, you will introduce yourself, but I must compliment you for the most brave, maybe, title of a discussion so far. The title of your discussion is Why Python Sucks. We won't skin you alive until you have finished, so you have some time to give some reason for your daring assertion, okay?
Okay. Yeah, so first of all, why do I think it's worth for me to stand here and talk about this topic? So I've been working for JetBrains for the last 10 years, and JetBrains as a company has been building tools for like a lot of different languages, starting with Java, C#, Ruby, Ruby, Python, PHP, and so on. And I've been involved in development of a few of those, and so and I've also been involved in developing Kotlin, which is our programming language that we built at JetBrains. And so I have like a bit of exposure to different technologies, and I think I can see like the upsides and downsides of different technologies, like maybe a bit more than some other people. And of course, I don't have any hidden agenda. I really like Python. I use it for a lot of my personal projects, and but still there is stuff that I consider to be missing in Python compared to some other technologies. So first of all, let's start with the language. So with the language, we have this weird situation where essentially because of the Python 2 and Python 3 split, the language evolution has essentially been frozen at Python 2.7 level. So even though there are new features in Python 3, for example, the talk that was at the conference about annotations has shown that many people are simply not aware that Python 3 has some new language features other than the Unicode support. And that's one thing. And another thing is that at this point, it's simply not really feasible for people to develop Python 3 only projects. And for example, there's PyParsing project, and PyParsing version 2 is only compatible with Python 3. And if you simply have your default Python set to Python 2 and you run pip install PyParsing, it will give you a syntax error, and it will actually cache this version of PyParsing somewhere in its internals, so that if you want to install PyParsing that works with your Python, you have to do some extra work clearing the cache. So what I'm saying is that by building a Python 3 only project at this point, you are essentially inconveniencing a whole lot of people and making life difficult for everyone essentially. And Guido has actually brought up this topic during the keynote at PyCon last year. And his answer to the language evolution is that, first of all, there is like too many, like it's bad to do too many changes to the language. So we were being conservative, and if you really miss some specific feature, then please use a preprocessor. Like write your own preprocessor that will convert your dialect of Python into like the standard Python, and then use that to write your code, which is a bad idea for like a large number of obvious reasons. And actually, my golden standard for language evolution is actually C#. So with C#, C# obviously has also a very large user base, like larger than Python, I think. And like every 2 years, every 3 years, something like that, they are coming with a major new version of the language that makes essentially so every version of C# essentially adds one change. So like or roughly speaking, so C#2 added generics, C#3 added link, C#4 added dynamic types, C#5 and maybe something else I don't remember, and C#5 added async await. And at this pace, so they are introducing features that matter to a very large number of users, and they are doing it at a reasonable pace, and they're like really tangibly making life better for users of the language. And that's actually the kind of evolution that I would very much like to see in the Python community. Unfortunately, it doesn't seem to be happening. And by the way, async await in C# is a solution to the same problem that yield from is trying to solve in Python, only that it's much nicer and much tidier and essentially works today. Then there are interpreters. Obviously, as soon as someone raises the topic of interpreters, like the answer is PyPy. Like there is PyPy, PyPy is great, PyPy is going to make everyone happy. I don't think so. There are a number of reasons why I'm saying that. So first of all, like the very approach of Python, of PyPy, like let's write the entire interpreter in Python, it sounds very attractive. So in terms of like attracting users, so that it's all Python. It's very easy to hack on, and it's very easy to do stuff with. Except that if you want to do something meaningful, other than changing a trivial bug in the standard library, you have to stare at Mandelbrot fractals for 2 hours, and you don't have any chance to make any meaningful contribution in the time frame of a sprint, for example. And you can compare that with, for example, the Rubinius project that exists in the Ruby community. So it's an implementation of Ruby language that also positions itself to some degree as Ruby written in Ruby. And what they do is they actually have like a very core small virtual machine written in C++, using like modern C++ VM development technologies. And then they write as much of the language as possible using the primitives provided the virtual machine and the language itself. So for example, the hash table implementation is written in Ruby. Like in Python, Python dict would be written in dict in Python in this case. And by having much more of the code written in Ruby, they have a much greater possibility for insights between different parts of. So the compiler can essentially see through the function calls and can do better job at inlining, at optimizing code, and essentially giving better performance simply through the benefit of making it possible to see stuff across boundaries of function calls. I think that that kind of approach is also much more hackable. So if you want to change something, you don't have to see through a long running generation process and stuff like that. You can simply go and change whatever you need and compile the interpreter, and it runs. And another point that I would like to make in this case is that PyPy has been around for a very long time, really long time. And the approach that they have been taking to solving the performance issues is essentially the same the whole time. It is nice and innovative, but in the time frame that they have been doing that, for example, Mozilla has gone through 3 generations of JIT technology. So they used to have a tracing JIT, and now they have another. There was Trace Monkey, Jagger Monkey, Iron Monkey, some other monkey. I'm not very deeply familiar with that, but the point is that PyPy has essentially stands still while the world around it essentially evolves and comes up with better ways to implement virtual machines. Yeah.
Isn't the one that's in Mozilla now correspond to what PyPy is? That is, PyPy is now, not.
And I couldn't hear you anyway, so.
So I was under the impression that the way that PyPy is now corresponds to what Mozilla is now. So Mozilla has gone through iterations to get to what PyPy is now. So PyPy was doing 10 years ago what Mozilla is doing now.
I don't think so. So what PyPy was doing and still is doing is essentially the tracing JIT approach. And as far as I understand, this is the trace monkey that is about to be, was recently removed from the Mozilla code base. So my understanding is that it's not what Mozilla is doing now. But anyway, it's tangential. We can discuss this probably a bit later. Another thing is Jython. And I recently had to essentially do some prototyping at work, like a web development project. And I didn't want to do this in Java. I wanted to use this dynamic language for this. And unfortunately, I had to choose JRuby rather than Jython. And the reason is that by being on the all of our web technology stack runs on a JVM. So we have monitoring tools, we have log analysis tools, we have simply ways to deploy and manage the web applications, and they all are tied to the JVM. And by being on the JVM, I can simply rely on all these tools being available and kind of pretend that, okay, you shouldn't care that I'm doing this stuff not in Java. It's just a WAR file, just like everyone else is doing. And Jython is unfortunately not mature enough for use in such environments. Yes, you can build WAR files with Jython. You can do this stuff. But the language is not really up to date. The performance of the implementation is nowhere near what JRuby can do, and so on. And being on the JVM is important in many cases, and unfortunately, Jython is not good enough for this yet. Next point is mobile. So obviously, we all have the Kiwi project, which we all love and which is doing some great stuff. But if you compare Kiwi to what the Ruby guys have, then you will find that again, there is no comparison. So first of all, they have the RubyMotion project. And RubyMotion is essentially a compiler of Ruby code to native iOS applications that can, iOS and macOS applications that can be deployed to the Mac App Store. You have full access to all the APIs provided by the operating system, and simply you don't have to use an IDE, use a nice language to write your stuff in, and the end result looks exactly like a native application written in Objective-C. The Android situation is a little bit better for Python, but still not good enough compared to Ruby. So in that, so we have this. There is this QPython project that is some kind of Python implemented on Android. But my understanding is that, please correct me if I'm wrong. I'm not 100% sure of what I'm saying right now. But my understanding is that, like all the current Android implementations on Python implementations, Android are based on the CPython code base. And so they have to restrict to something called PJNI use by Genius or whatever you call it to call the Android APIs. And this is limited. So you can call the APIs, but for example, you cannot implement an activity class in Python. You have to use the standard activity class that's provided by the framework and in some way plug into it. And in the Ruby world, there is Ruboto, which is based on JRuby. And essentially, you run JRuby on Android, and this is like a full-featured implementation of Ruby, and it gives you full access to all of the APIs that are on the platform. There is no restrictions, like you can implement classes, you can, I don't know, do anything you like. And you get fairly nice performance and very nice experience. The next question is the next issue is near and dear to my heart, and the issue is tooling. And there are like two aspects of that I'd like to mention. The first one is one that I have already brought up, which is introspection and profiling support. So in this case, unfortunately, Ruby has nothing to show us as a good example, but the Java and the C# worlds have a lot to show how like a real modern virtual machine can be implemented in this regard. So they expose a ton of information about everything that's happening inside the virtual machine. Garbage collection, JIT performance, you can see all the metrics of what's going on there, like trace every object allocation, trace every bytecode instruction being executed, and so on. And this gives you like great tools, great profiling tools that people can build. And like the application can analyze its own performance. So you can introspect your own virtual machine in which you are running and see if maybe you don't have enough memory, and maybe you are for some reason running too slow and would like to somehow troubleshoot the situation. And I don't see any sign of development in this area, none whatsoever. And the second part is like directly tied from what I'm working on, which is IDEs and static analysis tools. And I see again very low levels of interest for adding like optional static typing information to Python code. So there are these annotations that are in theory supposed to be used maybe somehow for adding type information. First of all, no one knows how exactly they should be used. There is no standard, there is no convention, there is no library that could make use of those. Second, it was stated very explicitly that the standard library will never have this information. So the Python standard library will never use annotations. And what this means that everyone working on a tool that wants to provide some smart code analysis support for Python has to redo all the work again. So we have a bunch of, maybe I'll be able to show something. So we have this file essentially specifying the types of the standard library functions, like what types the parameter have, what the return types are, and stuff like that. And we've had to build this information by ourselves. And there was a project at Google that did some similar stuff, I don't know, back in 2009 or something. And essentially everyone who wants to build a good tool for Python has to build up a database of this stuff. And that's really a shame and a lot of wasted effort. And again, there's like a bit of a chicken and egg problem, and the key reason is I don't see like any desire for this to change. Yeah, and for example, the OpenStack talk this morning was talking about like setting up a code review process for a project which has like 800 developers and 900,000 lines of code, and they want to have robust static analysis tools because it's the only way to maintain sanity when you have a project of this size. And the tools are not there, and they're not coming there, or like coming very slowly. And if you compare this to what's happening with other languages, for example, there are like multiple standards, there are multiple attempts to rebuild JavaScript with the purpose of providing better tooling. So there is Dart that Google builds, and there is TypeScript that Microsoft builds, and both of those, even though they are dynamically typed, they have all the dynamic typing infrastructure that still support all the dynamic typing features that regular JavaScript supports. They are fully statically typed, and they can they have like all the static type information that is required to build a robust IDE, to build refactoring tools, to build code analysis tools, and so on. And like vendors of many other languages are also concerned with tooling. The Scala developers, the TypeSafe is heavily investing into tooling. The developers of Groovy, the Groovy languages are also heavily investing into tooling. And here at PyCon, we are debating whether Vim is better than Emacs, and both of those were developed in the late 70s, early 80s, and haven't gotten much better since that time.
We are about that time.
Yes. And finally, there is one thing that I wanted to show, which is why I actually spent all the time messing with my screen, is this. There was a poster session at PyCon about the experience of novice people starting with Python. And you should just, I don't know, write this link down, write down this link somewhere and simply go and look at this. And despite all of the progress that Python is making in education and I don't know, spreading the joy of programming to more and more audiences, like outreach programs, like getting kids to program, getting, I don't know, ladies to program, and so on and so forth. Despite investing a lot into the community efforts, there is still not that much being done on the side of the language itself to make like this more novice friendly.
Just one question. So how do you compare Python to PHP? Is it at least better than PHP?
I find PHP like the most awful language and the most awful ecosystem in existence, so no comparison in this regard. I think I'm done. So that's what I wanted to say, and we have some time to discuss this, and please go ahead, criticize me and tell me why I'm all wrong and or what I missed and so on.
And if you will leave.
Yep.
Well, I guess you will leave. I want to remember just a thing to everyone. On our main site, europython.eu, on the main menu, you can find a voice telling mobile guide. You go there, you click, you download the mobile application, and you can vote normal talk and even builds open space. So if you enjoyed what he's saying, give him a good rating. Okay? Now,
okay.
For a question from the public, I leave you the mic.
Okay. I don't know. Any comments? Any? Okay.
Yeah,
It's on, I think.
Yeah. Yeah, I think it works. I liked your analysis a lot, especially at least the parts that I am aware of. I mostly would agree with you, and in particular, I think the situation, I think static typing, optional static typing, would be really useful and it would help a lot also with the performance problem, in my opinion, and perhaps would allow to do what Rubinius does, because you could rewrite the standard library using static typing and being high performant. You could solve that problem. So I think that's kind of a big thing, but I don't really see any progress, unfortunately. So
okay.
I don't know. I don't have any ideas.
Okay, thanks. You'll do that. Okay.
Thank you. Does it work? Okay. Two things. Well, I haven't touched PyPy in quite a bit of time, but the thing you said about the JIT, the tracing, and I think it's kind of different from the Mozilla implementation, but the PyPy JIT is actually built. Yeah, it's actually built to be, as far as as much as possible, agnostic from the implementation of your language, from how the methods are called. So you can have Topaz or that experimental PHP implementation built on it. So it's kind of natural that maybe it's not as efficient or something else. I mean, PyPy maybe is not as great as other projects like Rubinius in the Python ecosystem because, well, it does not integrate as well with C extension, unfortunately, because it's a hard problem. But it's a lot nicer, I think, research project, at least also before they killed it, there was also the object-oriented backend and things like that. So maybe we have too few practical uses for these alternative implementation, but I don't think it's so bad. The other thing is Ruboto. I looked at it some time ago, and it's, well, if you run a Clojure application on Android, it takes something like 6-7 seconds of startup time. Ruboto, it takes something like 15 seconds. Maybe they have been able to improve it, but I don't think that actually using any dynamically typed language on the Android VM is quite feasible nowadays. I mean, you can do something, but a few users probably appreciate it, and that's it. So, I mean,
they are both good points, but again, so as for PyPy, I'm not trying to bash on the PyPy project. So they're doing great research, but what I'm saying is that we need more experiments using other approaches to like other modern approaches to building good interpreters, and simply we need more innovation. And in terms of Ruboto, yeah, it's true that the performance problems are indeed there, but I think it is possible to work on them, and it's a battle worth fighting. So that's what I'm saying, and it's worth fighting not only on the Ruby front but also on the Python front. Yep.
First of all, I really liked your talk. I think it's valuable that we sort of all don't think we're all wonderful and everything's great. I think this is really valuable. Partly because I've got a lot of Perl experience, and I've been at this conference 3 years, and there's so many negative Perl comments which are completely unfounded. It's old Perl, out-of-date technology. But the real thing I want to say is I thought you would perhaps attack the threading in Perl, in Python. I think that to me is a weakness, the GIL, and all those issues. So how do the other languages like Ruby and C#, what solutions do they have in the threading area compared to Python?
So as far as I understand, the situation in the Ruby world is not significantly different from that of Python. I think they also have a GIL. Even in the Ruby 1, so they have actually rewritten the virtual machine in Ruby 1.9, so now they have like a real efficient bytecode-based interpreter instead of the AST walking interpreter, but they still have the GIL, and the problems are still roughly, okay, I don't really need this. The problems are still roughly on the same way. And the situation with JVM and C# are obviously much better because these virtual machines have very efficient threading implementations, they very scalable garbage collectors, very nicely detailed memory models for the VMs, and it's much, much better.
I'm a beginner Python tester in my company, so this is probably going to be a really naive question. But is the reason that C# and Ruby are ahead of us in certain places is because they have corporate backing?
Well, Ruby does not have any corporate backing. So Ruby, so C# is obviously backed by Microsoft, and they can hire very good people to work on it. But the Ruby is also essentially a community-developed language. So there is, it's mostly developed in Japan actually. So there is like it's like a whole other group of problems with like Japanese to English translations. I shouldn't go into it probably, but it does not have any major corporate backing. So there are companies doing commercial stuff with Ruby, just as Engine Yard, for example. Just as there are companies doing commercial stuff with Python, but all in all, it's the same level.
So we have a lot of, I've seen lots of signs with all the corporate sponsors. So is the Python Foundation pushing this sort of stuff, we want to go on down this track out to get some proper resource, or are we just hoping that the open source community will just develop something?
The Python Foundation, I think, does a very good job in general of supporting Python projects and solving problems in the Python community, and I'm very impressed by that. And by the way, I don't know any equivalent of that in the other language communities, and it's one of the big advantages of the Python world. But the thing is that in terms of, for example, of the language implementations, they seem to have decided that PyPy is where it's at. They are giving money to PyPy to fund its development, and I don't think they are really backing any other research to build alternative Python implementations.
Have you seen that the talk about the static compiler, the one that?
Nutka?
Yeah.
I've seen this talk at one of the previous conferences. I didn't go this year, but
I didn't quite understand what why he was saying that the mainstream of Python really is against this project and kind of sees it as that it shouldn't exist. Maybe you're aware of the details of why is the situation like that?
Not really, no.
But what do you think could that be useful as an alternative implementation which could kind of solve some of the problems?
I'm not sufficiently aware of the details, sorry, maybe, but I cannot claim it any other way, positively. Okay. So we're out of time, right? So we can continue outside or somewhere. So I'm still around here, would love to talk about this more.
And congratulations for proving your point in a not so popular topic.